Now that we know the structure of an atom, let's look at some of the interactions between atoms called chemical bonds. Chemical bonding happens when electrons are transferred or shared between atoms. So the location and number of electrons determines the chemical properties of an atom. Typically, we draw electrons in rings around the central nucleus. These rings are called electron shells. Each electron shell can only hold a certain number of electrons before it is full. We're going to look at the first 3 electron shells in this class. There are more, but you won't need those unless you take chemistry. The first shell is the smallest and the closest to the nucleus. It is full if it has 2 electrons in it. Hydrogen and helium only have the first shell. Hydrogen has 1 electron and helium has 2. So this shell is full for helium. The second electron shell can hold up to 8 electrons. The first 2 electrons will always go in the first shell, and then the next 8 electrons can go in the second shell. Carbon and neon both have 2 electron shells. They have the first shell full with 2 electrons. Carbon has a total of 6 electrons, so 2 of them are in the first shell, which means that the remaining 4 need to go in the second shell. Neon has a total of 10 electrons, so 2 are in the first shell, and 8 are in the second shell. This means that neon has a full second shell, but carbon does not. The third shell also only holds 8 electrons. Let's look at sodium and argon. Both of the elements have all 3 shells. Sodium has a total of 11 electrons. So 2 go in the first shell, and then 8 go in the second shell. And the remaining 1 will be in the third shell. It's nowhere close to full. Argon has 18 electrons. 2 in the first shell, 8 in the second shell, and then 8 in the third shell. This outer shell is called the valence shell, and it is the most important. For hydrogen, the outer shell is the first shell. For chlorine, the outer shell is the third shell. Which shell is the outer shell depends on how many electrons there are. If the outer shell is full, like helium, neon, and argon, that chemical is not going to react with other chemicals. These are called the noble gases, and they are inert. If the outer shell is not full, like hydrogen, carbon, nitrogen, sodium, and chlorine, these chemicals are going to be able to react. When chemicals react, they form bonds. Bonds are a way for them to fill up their outer shell. Think about it like this. Chemicals are happy when their outer shell electrons is full. A covalent bond forms when 2 atoms share electrons. A new structure formed by those 2 atoms sharing electrons is called a molecule. Hydrogen has 1 electron, which means it needs 1 more to fill up its outer shell. So hydrogen naturally shares electrons with other hydrogen atoms. Now they both have 2 electrons, and both have a happy full outer shell. Oxygen has 8 electrons. 2 in the inner shell, and then 6 in the outer shell. But the outer shell needs 2 more to get to 8 to be full and happy. So oxygen likes to do a double bond with another oxygen, sharing 2 pairs of electrons, or 2 covalent bonds with 2 hydrogens. Carbon has 4 empty spots in its outer shell, so it likes to form 4 covalent bonds. There are 2 different types of covalent bond, polar and nonpolar. The difference between these is really a really important concept in biology, so if you have any questions about this, please ask me. Let's start with the concept of electronegativity. This is how strongly an atom holds on to electrons. I like to think about it as being greedy. If an atom is really greedy for electrons, it has a high electronegativity. Oxygen and nitrogen have high electronegativities. If an atom is not very greedy for electrons, then it has a low electronegativity. Hydrogen and carbon both have about the same low electronegativity. So whether a bond is polar or nonpolar depends on the electronegativity of the 2 atoms being bonded. Nonpolar bonds are formed when the electronegativity of the 2 atoms are the same. So when hydrogen shares with hydrogen, or oxygen shares with oxygen, they are sharing with another molecule that is the same as them. This means that the electronegativities are the same. So H2 and O2 form nonpolar covalent bonds. Carbon and hydrogen also have about the same electronegativity. So the molecule of methane on the second from the right, which has one carbon sharing with 4 hydrogens, is also nonpolar. A polar covalent bond forms if the electronegativities are different. This happens in a water molecule. Oxygen has a high electronegativity, and hydrogen is low. So oxygen is more greedy for electrons. This means that even though the electrons are shared, they're shared unequally. The electrons spend more time around oxygen than hydrogen. Do you remember what charge electrons have? They have a negative charge. So if they spend more time around oxygen, oxygen is going to end up being slightly negatively charged. And since these negative electrons aren't hanging out with the hydrogen very often, the hydrogen ends up having a slightly positive charge. This is why it is called polar. You can see the polarity of a water molecule in the top right. The blue arrow shows that oxygen is holding on to the electron stronger than hydrogen. The top of the molecule, where the oxygen is slightly negative, and the bottom, where the 2 hydrogens are, is slightly positive. Sometimes it makes more sense for molecules to transfer electrons rather than share. Sodium only has 1 electron in its outer shell, so it would need 7 more to be full. Or it could just get rid of 1, so that it only has 2 shells, and that second shell is already full. Chlorine only needs 1 more electron in its third shell to be full, so it is very electronegative, or greedy. So when sodium and chlorine interact, chlorine steals an electron from sodium. Now they both have full outer shells, and they are happy. Don't forget that electrons have a negative charge. So because sodium lost an electron, which is negative, it now has an overall positive charge of 1. And since chlorine got 1 extra electron, it now has an overall negative charge of 1. These opposite charges attract. The positive charge of sodium and the negative charge of chlorine keeps them together in an ionic bond. Any molecule that has an overall charge is called an ion. These ionic compounds, called salts, tend to form very organized crystals. 2 slides ago, I told you that polar covalent bonds was an important concept. This is why. Polar covalent bonds can make a polar molecule, meaning it has a positive end and a negative end, like water. This allows for the formation of hydrogen bonds. Hydrogen bonds are actually just weak interactions between neighboring molecules, but they are extremely important in biology. Water is formed between 1 oxygen and 2 hydrogens. It is made up of polar covalent bonds because oxygen is more greedy for electrons than hydrogen. This gives oxygen a slightly negative charge and hydrogen a slightly positive charge. So what happens when a bunch of water molecules interact? They form hydrogen bonds. These slightly positive hydrogens form associations with the slightly negative oxygens. We usually draw these as a dotted line because they are weak and temporary. They are constantly breaking and reforming in liquid water. Reactions occur whenever ionic or covalent bonds are broken or made. An example of the reaction of hydrogen gas and oxygen gas to make water. On the left of the arrow are 2 molecules of H2 and 1 molecule of O2. The bonds between these molecules are broken, and 2 water molecules are formed with new bonds. The arrow tells you the direction of the reaction. Most reactions are reversible, so always be careful to look for the arrow. The molecules before the arrow are the reactants, and the molecules after are the products. The reaction must always be balanced. 4 hydrogens go in, and 4 hydrogens come out. 2 oxygens go in, and 2 oxygens come out. We're not going to spend much time on balancing chemical equations, but if you go into chemistry, it'll be very important.